So hi everyone, my name is Shivam Bohra. Welcome to CodeChef's official YouTube channel. In this video, I'll be solving this problem called as prefix sum, which appeared in September Lunchtime 2021. The difficulty level of this problem is simple, and the prerequisites for this video is the sum of an AP and the sum of n natural numbers. Now, some of you might not know what a prefix sum is. So here, I'll give you a quick explanation of how do we calculate this prefix sum, right? So here I have an array, and over here I'm using zero-based indexing. So at index 0, my prefix sum would be the very first element or the element at the 0th index, right? So the element at the 0th index is 1. So the prefix sum till this point is 1, right? At index 1, the prefix sum would be the sum of elements till this point, right? So till this point, I have these two elements. So I'll add these two. So now I have 1 plus 2, which is 3. So the sum of elements till this point, or the prefix sum at index 1, is 3. Similarly, at index 2, I'll take this array or this sub-array. So the prefix sum till this point would be 1 plus 2 plus 3, which is 6. Similarly, I'll add 4 to this 6 to get 10, then 15, and so on, right? So this is the prefix sum for their respective indexes, right? So the problem says that for a positive even integer n, we call a pair of arrays A and B to be interesting if they satisfy the following conditions. So this means that for n, which is an even positive integer, we call a pair of arrays A and B to be interesting if they satisfy these conditions, right? These given conditions. So the first condition is the size of array A is equal to the size of array B, which is n by 2, right? Each integer from 1 to n occurs exactly once in exactly one of the arrays, which means that if we combine the array elements of A and B, then we'll have all the elements from 1 to n exactly once, right? The ith prefix sum of A is not equal to the ith prefix sum of B for all I 1 to n by 2 minus 1. So this means that except for the very last element, the prefix sum for the remaining indexes, except for the very last one, should not be equal for A and B, right? And the sum of all elements of A is equal to the sum of all elements of B. So this is a quick example which satisfies all the conditions. Let's say the value of n is 8. So the size of first array should be 4, and the second array, which is B, should also be 4, which is half of n. This first array is having elements 1, 2, 7, and 8, and the second array B is having elements 3, 4, 5, and 6, right? So if we combine the elements of these two arrays, then we should have all the numbers from 1 to 8, which is n, exactly once, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have all the numbers from 1 to 8 if we combine the elements of these two arrays, right? So this is the first condition, that the size of these two arrays should be equal and should be half of n. This is the second condition, that all the elements from 1 to n should be present when we combine the elements of both the arrays. And the third condition was the prefix sum if we ignore the very last elements. So the prefix sum till this point should not be equal for both the arrays, right? So let's compute the prefix sum for A. So we have 1. So the prefix sum till this point would be 1. Then we have 2. The prefix sum till this point would be 1 plus 2, which is 3. Then we have 7. The prefix sum till this point would be 10, right? And then we have 18. For now, let's just write it, but we have to ignore it because we are not including this very last element, right? So over here we have 3. So the prefix sum till this point is 3. Then we have 4, so 7. Then we have 5, so 12. And at very last we have 6, so 18, right? So the third condition was except for the very last element, the prefix sum for the remaining elements should be different. So we have 1 3 3 7 10 12. So you can see that the prefix sum of these two array elements are different, right? So 3 is satisfied. The fourth condition was the sum of these two arrays should be equal, right? Now, if you see this, the prefix sum at the very last element. So over here, I have 18 for the first array. So the prefix sum of the very last element means that the prefix sum of all the elements till this point. Now you can see that we have added all the elements of the array. So this, the prefix sum of the very last element is simply the sum of array elements of A. And over here, this prefix sum of B is also the sum of array elements of B, right? You can see that both are 18. So sum of A is equal to the sum of B, which was the fourth condition. So here, all the four conditions are satisfied, right? So we are given a positive even integer n. And if for this n, if we are able to make these two arrays A and B such that these two arrays follow these four conditions, then in that case, we would print yes, and then we would print those two arrays for this n, right? And if there exists multiple interesting pairs, if there exist multiple possible solutions for this case, then we can print any of these. And if it is not possible to make A and B for the particular n, then in that case, we would print no, right? So in the first line, we would have t, which is the number of test cases. And for each test case, we would have n, right? And test cases could be up to 10 to the power 5, and n could also be up to n to the power 5. N is definitely going to be an even integer. And this is the sample input. That is, we have two test cases. The first test case is 2, right? So n is 2. So we have to make two arrays of size 1, 1 each. And these two arrays should contain all the elements from 1 to 2. So in this case, if one array has 1, then the other array must have 2. So one array will contain 1 and the other array would contain 2. The sum of these two arrays is different. So this would not be, or it would not be possible for us to make arrays A and B which satisfy these four conditions, right? Hence, for this case, our output would be no, right? Now let's take the second case, which is 4. So for 4, it is possible to make two arrays which satisfy those four conditions. So answer would be yes. And so first array is 1, 4, and the second array is 2, 3, right? So you can see that the sum of this array is 1, 4, which is 5, and the sum of this array is 2, 3, which is also 5. So the sum of both the arrays are equal. The prefix sum for except the very last position is 1 in A and 2 in B. So it is different for both the arrays except for the very last element. And yeah, so that completes all the cases, and the size of both these two are also 2, which is half of 4, which is n. So these two satisfy all the four conditions. So answer would be yes, and this is one possible answer, right? So now let's move on to the approach. So the fourth condition says that sum of A is equals to sum of B, right? That is, the sum of both the arrays is equal. And also the second condition says that if we combine the elements of A and B, then we would have all the elements from 1 till n exactly once, right? So for this case, where n is 6, we would have elements from 1 till 6. So we would have 1, 2, 3, 4, 5, 6, right? If I find the sum of all these elements, these elements, it would be 21, right? So the sum of elements of all these elements, 6 elements, is 21, and also sum of A is equal to sum of B. So tell me, is it possible to break this total sum into two equal halves? The answer is no. We cannot divide an odd sum, right? We cannot divide an odd sum into two equal halves. So my first condition would be if sum of all the numbers, which is numbers from sum from 1 till n, if sum of 1 till n is odd, right? If sum of 1 till n is odd, then we would straight away print no, because it is not possible to make two arrays having equal sum, right? So this is my first condition. If the sum of elements from 1 to n is odd, then we would straight away print no. Now you may use a loop for this, but this would increase the time complexity. Hence you can also use this direct formula of n into n plus 1 divided by 2, right? So this is the direct formula of finding the sum of n numbers or n natural numbers. So we can see that when n is 2, the sum of numbers from 1 till n is 3. When n is 4, the sum is 10, n is 6, sum is 21, n is 8, sum is 36. So when n is divisible by 4, the sum is even. N is divisible by 4, so the sum is even, right? And when it is not divisible by 4, the sum is odd. So let's mathematically prove of why the sum is even. The sum is even when n is divisible by 4. Divisible by 4. So when n is divisible by 4, we can write n as 4 into x, 4 into some integer, right? 4 into some integer. We can write n as 4 into some integer because n is divisible by 4. So sum of n natural numbers, that is numbers from 1 till n, is n into n plus 1 divided by 2. So it is n by 2 into n plus 1, right? Now n is divisible by 4, n is even, so n plus 1 would always be odd, right? Because n is even, so n plus 1 would always be odd. Now this n could be written as 4 into some integer because n is also divisible by 4. So this is 4 into some integer. If I divide it by 2, then the whole term is 2 into x, 2 into some integer into some another odd integer, right? So 2 into anything would always be even, right? Hence, when n is divisible by 4, sum is even, right? Similarly, when n is not divisible by 4, in that case, we can write n as 4x, which is divisible by 4, plus 2, right? Why not plus 1 or plus 3? Because 4x plus 1 would be odd. And since it is given that n is always going to be even, so we have to make it even. So 4x plus 2 would be even, as well as 4x plus 2 would not be divisible by 4, right? So 4x plus 1 would be odd, hence we are not taking it. 4x plus 3 is also odd, hence we are not taking it, right? And 4x plus 4 is divisible by 4, so we want it to be not divisible by 4, hence we are writing it as 4x plus 2, right? So this is the sum of n natural numbers, then n by 2 into n plus 1. N is even, it is given in the question. So n plus 1 is odd, is always going to be odd. We can replace n by 4x plus 2 over here. So 4x plus 2, right? 4x plus 2 divided by 2. So I'll divide it by 2. So it is going to be 2x plus 1. Now this 2x is 2 into some integer. So this is going to be even. So this whole term is going to be even. Even plus 1 is always odd. So the first term is all odd, second term is also odd, and odd multiplied by odd is odd, right? So when n is not divisible by 4, then sum is always going to be odd, right? So in the previous case, if n is not divisible by 2, sum is going to be odd. If n is divisible by 4, sum is going to be even, right? Now let's take the cases in which n is divisible by 4, right? Because if n is not divisible by 4, we can simply print no. Now n equals to 4. So we have numbers from 1 to 4, right? And we have to use all these numbers to form two arrays, A and B. So we have already seen this case. This is about the test case in the problem statement. So over here, A is formed by taking 1 and 4. So we are taking 1 and 4. And B is formed by taking 2 and 3. So we are taking 2 and 3. So we are taking all the numbers from 1 till n. Now, we already know that these two arrays are going to satisfy all the conditions. We have seen it previously. Now let's try to observe a few things. Now over here I have taken 1 and 4, and in the second array I have taken 2 and 3. Now I'm only talking about the cases in which n is divisible by 4. So such arrays in which n is divisible by 4, I can always break those arrays into 4 equal parts, right? So in this case, I can break this array into 4 equal parts. So I'll have 1, 2, 3, and 4. I'll take the first part and the fourth part. I'll take the second part and the third part. I'll take the second part and the third part. And using 1 and 4, I'll make A, and using 2 and 3, I'll make B, right? So 1, 4 are making A, and 2, 3 are making B. And we already know that these two arrays are going to satisfy all the conditions. Now let's see whether they will satisfy these conditions for 8 or not, right? So firstly, I'll write all the numbers from 1 till 8. So 1, 2, 3, 4, 5, 6, 7, and 8. I'll divide this complete array into 4 equal parts because n is divisible by 4. So we can divide it into 4 equal parts. So 1, 2, 3, 4, 5, 6, and 7, 8. This is the first part, second, third, and fourth. We'll combine the first part and the fourth part. So 1, 2, 7, and 8. So 1, 2, 7, and 8. We'll combine 3, 4, and 5, 6. So 3, 4, and 5, 6. So 3, 4, and 5, 6. And we have already seen that this condition or this case was true. We have already seen this case previously. And so now let's mathematically try to prove that this array A, which is formed by taking the first part and the fourth part, and this array B, which is taken by the second part and the third part, would always produce a sum half of, this would always produce a sum half of sum of numbers from 1 till n, right? Because this is the total sum after adding all the numbers, and A is supposed to have half the sum of this, and B is also supposed to have half the sum of this. On combining these two, I'll get the complete array, right? So let's try to prove that 1 and 4 on combining forms half of sum of numbers from 1 till n, right? And if we prove this, this would automatically get proved. So the first part and the fourth part would have equal number of elements, that is n by 4. And also the first part would start from 1 and would go till n by 4, right? Similarly, the fourth part would start from 3n by 4 plus 1 and would go till n, right? Now, using the sum of AP formula, I can calculate this value 1, 2. I can add all these numbers 1 plus 2 plus 3 and so on till n by 4 and get this value n square plus 4n by 32. Similarly, I can also solve it for 4, part 4, and I can get this value 7n square plus 4n by 32. And if I add these two, I'll get n square plus n by 4, right? This is the LHS, that is on the left hand side. Similarly, sum of numbers from 1 till n is n into n plus 1 divided by 2, and since we already have a 2 here, so it would be n into n plus 1 divided by 4, right? So this term is nothing but this term, n square plus n by 4. So RHS is also n square plus n by 4. LHS is also n square plus n by 4. Hence LHS is equals to RHS. So on adding 1 and 4, I'll always get half the sum of elements from 1 till n, right? So on combining the first part and fourth part, I'm getting half the sum of elements from 1 till n. So if 1/2 is this, then the remaining half would also be half of sum of elements from 1 till n, and the remaining elements are in 2 and 3, right? So both A and B are having an equal sum, right? So the fourth condition, that is both A and B should have equal sum, is satisfied. Also, you can see that the size of this first array is n by 4, or in other words, the size of all the four parts, the size of all the four parts 1, 2, 3, and 4, 1, 2, 3, and 4 are n by 4. So size of A would be n by 4 plus n by 4, which is n by 2. And also the size of B would be n by 4 plus n by 4, which is n by 2, right? So the size of both the arrays are also true. So this is the first condition, or this was the first condition. So this is also true. Now we have already seen that the first case and the fourth case are true. Now let's try to verify the second case, that is all the numbers from 1 till n should be there after combining the elements of A and B, right? Now A is basically the first part and the fourth part of this range from 1 till n. B is basically the second part and the third part of this range. So we are using all the numbers in this range, hence even condition 2 is satisfied, right? So now we are down to the third condition, that is the prefix sum of all the elements except for the last one should be different in array A and array B, right? Now I have divided these two arrays A and B into two equal halves. One half would contain this 1 and 2. This is 1 and this is 2. And the other half would contain 3 and 4. This is 3 and this is 4, right? Now, in the first half, we can see that the prefix sum of the very first element is 1, and over here it is 3. For the second element it is 3, and over here it is 7. So this difference of prefix sum is 2, and this difference of prefix sum is 4, right? And even if we have more elements in this first group and second group, then the difference would keep on increasing, right? So till the first half, this difference would keep on increasing because one or the group first has smaller elements as compared to group 2, right? So this difference would increase. Now during the second half, we have 4 and 3. Now this time, this first array has larger elements. So this time this difference would decrease, right? This time this difference would decrease because now 4 has larger elements. So now sum would increase faster in A and slower in B. Hence the difference would decrease. And this difference would become 0 at the very end. This difference would become 0 at the very end. So except for the very last element, either the difference of their prefix sum would increase or it would decrease, right? But it would never become 0 until the very last position, right? So even the third case is satisfied, that is their prefix sum would never be 0 unless it is the very last position, right? So moving on to the code, firstly I'll input t, which is the number of test cases. Then using a loop, I'll iterate t times. Then I'll input n. If n is divisible by 4, it means that the sum of first n natural numbers is odd. So we will simply print no, because we cannot divide that sum into two equal halves. Otherwise, we'll print a yes, right? So using these two loops, right? So this is from 1 till n by 4. This is the first part. This is from 3n by 4. Q3 is 3n by 4 plus 1 till Q4 till n, right? So 3n by 4 plus 1 till n is the fourth part. So this is the first part and the fourth part. So these two together would form array A. Then I'll leave a line, and using this loop, this includes the second part and the third part, I'll print the array B, right? So let's just run this code. So we'll have three cases. 6, 4, and 8. So for 6, we know the answer would be no. For 4, the answer would be yes. So for 6, the answer is no. For 4, the answer is yes. So it would be 1, 4, and 2, 3. And for 8, the answer would also be yes, right? So 1, 2, 7, 8, and 3, 4, 5, 6, right? So let's just submit the code. So this is the exact same code. So I'll click on submit. So here we can see that I got the correct answer.